Hey, you guys, can I share what Katie was sharing with me? Would you guys mind? What Katie said was she set this equal to this and then just solved for A. And I said, well, what did you do? Like, what is that? Why did she do that? And why is that legal? Why is that what we wanted to do here? What is she doing? What's the mathematics behind, and then you put x is equal to 2, right? Both of them, so you put that value in. What is that? Because I said what you should have done is set one equal to the opposite reciprocal of the other one. Then you'll get a number, right? Doesn't that make sense? Opposite reciprocal. I've heard of that before, right? It sounds really good, yes?
The reason she did that was because in order for the two equations to be continuous, or like when they meet at that one point, they have to be equal. Because if they're not equal,
What has to be equal?
both of the function values for the equation.
But it can't. Okay, so here's the difference. This function does not exist at 2. Doesn't exist.
Right, but the other one does.
Doesn't exist.
But the other one does.
But what are you doing though? So like you're right there. What's the word I'm looking for?
It has to approach that value.
So you're saying it all. What's the word I'm looking for?
Limit.
Yeah, you know what I'm saying? You just literally, what you did in algebra, meaning you create an equation, you literally set the limit from the left equal to the limit from the right. See what I'm saying? And that's what you said. You like approaches. It's exactly what you did. Does that make sense? You algebraically set the limit from the left. This thing. So this thing, as it approaches 2, it's following this rule. So you plug in a 2 into here, and then that's where this thing is going from the limit. What it's approaching from the left. This thing doesn't exist at 2, so you can't just like plug in values. It's kind of illegal. But if you talk about limits, and as you approach from the right, these are the good words. It's going to follow this rule. So if you set those equal, what you did is you set the limit from the left equal the limit from the right, which is what you want in order for this function to be continuous. Does that make sense? And then you get 3. And if you graph it, you see those two lines hook up. Did anyone graph those two lines? Well, I mean, you can graph a line. You can graph 2x plus 3. Yeah. Let me ask you this. Did anyone find the function value first and go from there? Did anyone find f of 2?
Yeah.
Yeah. And then what did you do from there? It's kind of a different way to look at it. What was f of 2? How did you figure out f of 2 so quickly?
I put it into the function, the one at the top.
Yeah. And you got?
7.
And then what did you do with that?
Then the other one had to approach 7.
The other one had approach 7. Does that make sense? Now in this case, you guys, can you just plug in 2 to get the limit value? Well, technically, you know what I'm saying? I don't know, because it follows this rule. Now, could someone figure out in the second problem what in the world that this means? Like, how do I even get started? Check out the second problem, this 50. Let me straighten it out. So kind of same idea. It's 2 functions. But what is that absolute value of x plus? What does that even mean?
Plus or minus.
Be a little more specific. Like, I want to know what x values follow which rules. You know what I'm saying? Like Roxana, if I plug in a 0 into the function, would it follow the top or bottom rule? Top. What if I plugged in a 5? Would it follow the top or bottom rule? What do you think? Eric?
Bottom row.
Yeah, what if you plugged in a -7? Does that make sense? What follows what as far as that absolute value? So it's going to follow the top rule for x values between -2 and 2. And it's going to follow the bottom rule for x values bigger than 2 and equal to, and less than -2 and equal to. So with that information, see if you can solve for this b to make this thing continuous. At 2, just at 2,